So today we're going to go ahead and solve a problem involving two-dimensional circular motion. So first thing let's go ahead and read the problem and then draw a picture. So this is a popular amusement park ride. So we have a cylinder rotating on a vertical axis. So here I'm going to go ahead and draw the cylinder, and it's rotating around a vertical axis. So it's like spinning like that. So the circle is like in the horizontal direction. So the radius we know is 6.2 meters. Let's see what else. Rebecca stands inside with her back against the wall of the cylinder. So Rebecca, we don't have a mass for Rebecca in the problem. Let's say this is our friend Rebecca, and let's just call her a mass of M. Okay, with her back against the wall of the cylinder, just as we drew that. The ride rotates and presses Rebecca against the wall of the cylinder, and when she reaches the speed V, okay, so speed V, the floor of the ride drops so that she can no longer stand on it. The coefficient of static friction between the wall and Rebecca's clothing is 0.82. What should Rebecca's minimum speed be V when the floor is lowered but she does not fall? Okay, interesting. So let's go ahead and just to start, let's go ahead and draw our free body diagram. So let's see, we have the wall pushing in on Rebecca. So that is going to be the normal force. And again, to really get your best out of this video is make sure to try these steps yourself and then check back in on the video. So draw your free body diagram yourself and then check back in on the video. So again, we always have gravity pointing downwards. Gravity's always down if something has mass. What prevents Rebecca from sliding down? So the answer is the friction on the wall prevents Rebecca from sliding down. So if we go ahead and set this up, okay, cool. We have that. Whatever. Let's go with that. And FG we know is going to be MG. Okay. So next thing let's go ahead and draw our coordinate system. So we'll say this is the X direction and upwards is the Y direction. Okay. So now, and again, it's moving in a circle in the X direction, the horizontal direction, not the Y direction. So let's go ahead and set this up. So we have for X direction, let's set up F net C. Right? Yeah, because it's moving in a circle in the X. And then the Y direction, let's just go ahead and set up normal F net, because it's not moving in a circle in the Y direction. It's only circle in the X. So what I want you to do is now go ahead and take a guess what you set F net C equal to, and then F net equal to, and start plugging in things, and then check back in on the video afterwards. Okay, so F net C, we have, and again, we say towards the center of the circle is the positive direction. So for F net C, we just have Fn. For F net Y, we have FF going upwards minus FG going downwards. Okay, so let's go ahead and start to plug things. So in the end, we want to find speed V. So F net C is going to be M times AC. We're not given a centrifugal acceleration, but we know AC is going to be V squared over R equals Fn. And we want to find the velocity V. Cool. That's what we want to find. We know R, so we can plug that in. We don't know M, so hopefully that cancels out at the end. Fn can't be in our final answer. We're going to get a number at the end. So let's see. Let's look at Y and see what happens. Okay, so FG, that's an easy one. I know that's going to be mg. FF is going to be our coefficient of friction times our normal force. F net we know is mass times acceleration. Okay, so now let's think about a couple more things. What's the acceleration in the Y direction? Okay, Rebecca is not moving up and down at all, so her acceleration is just going to be 0. So it's m times 0 equals mu times Fn minus mg. Cool. So m times 0 cancels out. So this is 0 equals mu times Fn minus mg. Oh, nifty, nifty. Let's think about what you could do now. Oh, let's go ahead and solve for Fn. So mg equals mu times what? Fn? So Fn is going to be mg over mu equals Fn. Let's go ahead and plug this in over there. So Fn is going to be what? Mg over mu, m times v squared over r. Ha ha ha, this is very fun. Okay, we want to find the velocity, so let's cancel out m. So velocity is going to be v squared equals what? Rg over mu. So v in this case is going to be what? V is going to be square root of Rg over mu. And now let's go ahead and plug in our numbers and see what we get. So R is 6.2, G we know is 10, mu is the coefficient of friction, which is 0.82. And when I plug that all in, I get the velocity to be 8.7 meters per second. So that is the min speed for Rebecca to keep on spinning in a circle. Cool. Thanks for watching.